Happy Cinco de Mayo. Cinco de Mayo. Cinco de Mayo. Yesterday was the 4th of May. May the 4th. May the 4th be with you. And that's pretty bad. And here's Darth Vader in Cinco de Mayo garb saying, "Yo soy tu padre." We celebrate cultures, we celebrate ancestry, we celebrate our stories, and when you don't have printing press, you write your stories in the stars. And so we sit back with our ancestors and we think about how they saw things and what they wondered. Not taking them literally, they don't have the telescopes and the technology and the knowledge of physics, etc. They don't have cell phones. They didn't know that kind of stuff. They knew how to interact, right? And so they watched, and they made up their patterns, and they told their stories. You can connect those dots however you want, and people did connect them differently. You could see a dog, front leg, back leg, tail, back, front leg, back leg, tail, head, kind of a triangle. Sirius, the dog star, the brightest star in our sky, besides sun, of course, always. Magnitude about -1.5. And we have that, Canis Major, Canis big, or dog, Major big dog. Okay, and we notice that we see that facing south. So we see this. There it is. There it is. We wouldn't see that many stars with our naked eye. This is taken with a camera with a large opening. It lets in more light. Oh, now it was rising in the east, setting in the west. Now it's rising still in the east and setting in the west, circling around that one star Polaris, right? Circling around Polaris, the North Star. So this is east. Wine. Whereas the other way, it was eat sandwich. And we saw these dots in the sky and we wondered about them. We couldn't see individual stars move. And we come back to where we were. And we say, okay. Chapter 11, it's time. It's time to dig into stars. We're joining our ancestors, our human journey, wondering, our art, our stories, our science. With naked eyes, for thousands of years, that's all people had. So with naked eyes, people looked at stars as dots. They're dots. They just noticed that. They didn't know what they were. They didn't know. They're streaks. Saw streaks. What are they? Bad luck. Oh no, things happen. You wonder why. Why do things always happen that way? Well, it's because you want one thing and 100 things could happen. So probably you're not always going to get what you want. But as the Rolling Stones said, you get what you need. Okay. We saw that some dots and some big circles didn't move together with the stars. I mean, they moved together with the stars in one day, right? One day, one night, they moved together. But if you look closely, week to week, and certainly month to month, there's quite a bit of change. And each day, moon changes quite a bit. And so these were called the wanderers, right? Greek word for wanderer is planet. But these aren't what we think of as planets now. These are not planets. We think now of those planets. Now, they didn't see, of course, Uranus. You might be able to see in a dark sky, but it doesn't move very fast because it's so far away, right? Things far away don't appear to move very fast. And besides Kepler's third law, Uranus is out farther from sun. It's got a longer path and it's traveling slower. So it didn't seem to move if you even noticed it, right on the edge. 5.5 magnitude, 5.5 or 6. We're going to talk about that in a second. Neptune, magnitude around 8, wasn't even known. Didn't know it existed. It's like, well, how are you going to put that in astrology if the planets are supposed to rule? There's a lot that wasn't. It's okay then, but now we can be real, we can be honest. What everybody would agree on now and then is that these folks, these things, are seen in a strip of sky. Now you don't have to call it the zodiac, look at Chinese astrology or astronomy. Astrology from the old way of thinking about it, the old stories, the old trying to figure things out, right? And now we've moved past that. Things rising in the east, right? Each night moving together, but always finding sun, moon, and planets in that strip, and now you know why. So we've talked about streakers, talked about planets in a lot of detail, our planets, and considered thinking about other planets around other stars that we know now, we guessed that they existed, but we know with the evidence, the data since 1996. We studied moon quite a lot, and Apollo and explorations, etc. So we need stars and sun, right? These are, we need to study those, and we're going to do that now. Now, in chapter 1 with our naked eye, we saw stars as glowing dots. What are they? I don't know. Are they big? Are they small? I don't know. Are they holes in the ceiling? Fires coming through? I don't know. Stop bothering me. No. So you can wonder, but you may die not knowing. We wonder about dark matter and dark energy. I may die not knowing, right? You may die not knowing. Is there life out there? There's super good odds, but I may die not knowing. I don't know. When we find that out, we'll see. We can wonder. But we got to wonder and take some steps. What can we notice? What can we do? We can notice how bright those dots appear. The apparent magnitude, sometimes called the visual magnitude, lowercase m, details are where it's at. Capital M is absolute magnitude, and that ranks luminosity. We didn't go there, and the book gets a little confusing. Apparent magnitude, that's just how bright it looks on that, when we looked at that starry night sky, right? How bright, oh, Sirius looks the brightest, yay, it wins. You could give it a first place, and you would if you're doing it by eye. And then you give second place, and then third and fourth. But then when you've got a telescope hooked up to a computer and a detector that can tell you how much light you're getting from each, then you can rank it and you can extend it lower than one, meaning brighter. Colors, sort of 4 shades. Our eyes have it's pretty hard to tell the difference between red and orange. So I kind of say red, orange, yellow, white, blue, white, 1, 2, 3, 4. We don't see green stars and we don't see purple stars. They give off green light and they give off purple light. We talked about that in chapter 10. Okay, angular separation. A, W. There's an angle between those. But if I don't know how close they are to me, I really don't know how far apart they are. So there's the angular separation between stars. And then we notice that as planets move, their separation between stars changes. Sun and moon wander. Their separation between stars changes. The angular separation, we measure the angle, or visual, or you can call it apparent separation, because you don't know this, you know this. Okay, cool. So we notice these things, and we notice patterns. I mean, the stars are where they are, and you could then connect the dots and tell your stories, but I could tell my stories, right? Star Wars. And we can tell our stories, and one isn't better than the other or more right than the other. When it comes to science, there is a more right than the other. There is a more justified or validated by evidence than another. But the things we don't have evidence about, you and I might wonder. Big Bang, what a stupid idea. Oh, wait, more and more evidence. I guess you're right. Seems to be, just keeps holding up. We'll see, right? So the patterns are, the dots are there, and they move together, east to west. They move together, and so the patterns move. How you connect the dots is up to you. And the stories you put to them is all made up. Leo's made up, and Gemini, it's just made up. It's just the Greek, what the Greeks I mean, all due respect, I mean, right, to all the cultures, but they aren't the only ones. So the Gemini story is just that story, and the Leo story is just that story. Sagittarius is just that story. I mean, there's no meaning to that other than someone made up that story. Anyway, eat sandwich. They rise and set. Drink wine. They rise again in the east, but I've turned around, and now what was on my left is now going to be on my right. Rise and set around us. Find Sirius, the brightest star in the sky. Find winter's a good time. Find Polaris, the North Star, always. Day, night, any season. There. Interesting. Okay. Did we get that? Did I get it all in? All right. Let's take a look over here. Let's zoom out. So I think it's a nice opportunity to review and pull all this together. We're coming to the close of this course, most of the semester. We've studied a lot and wondered a lot, and we can really pull it together. And I hope it's getting easier for you to retain this and to step outside and kind of try to grok from a science fiction novel, try to get it all. Our solar system in chapter 7, we said how it formed. Well, that told us, that sun formed at the center. But that gave us a good example, a good introductory idea of how stars form. And so we can go back to that and say, hey, and even if we go back to chapter 0 in the beginning and chapter 7, we can see this summary of universes. Well, maybe, right? We don't know, multiple universes parallel. But universe, within that eventually forming galaxies, within the galaxies forming stars, and the stuff going around them. We have this idea, okay? Now the problem is, when we talk about the beginning of the universe, know that when people were making up stories, they didn't know. They had all kinds of stories. They made them up. They didn't have data, evidence, etc. Now we do. And we keep challenging that idea, but it keeps standing up. We will see. Maybe it won't. But the best understanding is that our universe started, and I'm just going to round it off to an easy 14 billion years ago. The trouble with that, let's do this. 14 billion years ago in the what? Big Bang, which was named by someone making fun of the idea, then it shows up. It's not really an explosion because there wasn't anything to explode. You can't do a little chemistry experiment and explode something because there's no atoms in the beginning. What is there then? What's in the before? What could there be? Space, time that's stretched and ripped, and we kind of look at that, but it's hard to say, right? So you got to know what you can know, and what you want to know, and inch forward with the details. Okay. The trouble is that is way too long ago to imagine. We can't. That's why I never get bored. It's too much. I can't imagine this. Astronomers, you can try. You can say, well, this compared to this, but it's just too long a time to imagine. Check up on you. Okay. And then after that, you saw some steps, but it quickly became just hydrogen and helium. Hydrogen being one proton. It could have a neutron too, but what determines the type of atom is how many protons. And it could have an electron or not. Electrons are easy to rip off, so I'll just put an E minus. Oops. E minus. And it orbits kind of like that, but they're more complicated than that. They show wave-like properties, all kinds of all kinds of deep stuff that we do use in technology, quantum mechanics, kind of crazy stuff. Anyway, but hydrogen is the simplest atom you can make, one proton. You can't make 1.5 protons, you can only have one proton. The next simplest atom, named after our sun, Helios, is helium, 2 protons. Now protons need some help, they need some counseling for that nuclear family to stay together, so they generally have 2 neutrons. Electrons, well, they can get ripped off, but generally, you might expect 1, likely 2 electrons. But even if those are ripped off, we still call it helium. This is also called alpha, if you want to study radioactive decay, but alpha part. Anyway, so now we've got this big cloud. Now here's the key. The universe continued to expand and cool. Atoms slowed down. They had slower collisions. You see, it took big collisions of protons had to come in and smash into each other and get close enough to fuse. And we're going to talk about that. That's the essence of stars. So it's interesting. In the very beginning, there were no stars. There was no carbon. There was no iron. There's no metal, right? There's none of that stuff. There's no rock. There's just this. And you got to somehow build up the atoms, bigger and bigger atoms. Carbon has 6 protons. Who's going to build it? Oxygen's got 8. Who's going to build it? Iron's got 26 protons. Who's going to squeeze them in there? They don't like each other until they get really close. And here's a problem. The universe is expanding. Well, wait. I mean, when it's really hot, they can run into each other fast and maybe get close enough to fuse, right? But they slow down, and no bigger atoms could be formed, which is a big uh-oh. Uh-oh, uh-oh. No life. Done. What a boring place for Darth Vader to rule. Crazy. How did life happen? Clearly it did, right? Clearly it did. If you go to a Cinco de Mayo celebration, you'll see some good life. We're going for enchiladas, ensalada, right? Ensalada. Or enceladus. Enchiladas, ensalada, enceladus, and nachos tonight. That's what we're doing. Put on some good music, Los Lobos, whatever. All right, so know the story. Then we got galaxies after the word, same word as the root gallon, or milk. Milk. Galaxies are formed about within the first billion years, let's say. Probably a little less, but within that. So let's just go with 13. That's nice. You can remember that. 14, 13, right? First nothing, and then a bunch of hydrogen and helium. Mostly hydrogen. Then you got galaxies, these clouds, if you want to think of it. But that's way, again, too long ago to imagine. Too long ago to imagine. Right? And way too big to imagine. And so it makes astronomy hard to conceptualize this. It's not normal unless you study what people have figured out over with the scientific method, kind of starting with Galileo and Newton, and people before, all those people inching forward. Anyway, the galaxies formed kind of in groups or clusters of galaxies. Was dark matter at the root of it? We don't even know what dark matter is. We know there's something wrong, either we don't understand, or something, still on that journey. Inside the galaxies, each galaxy of this cloud, there are groups, it broke up into separate clouds within the galaxy, and the clouds of hydrogen and helium gas clouds pull together. And within a cloud, a giant molecular cloud, cold cloud, you have a bunch of stars forming together within the galaxy, right? So you got all these galaxies, and then within the galaxies, you get little groups, and then lots of stars forming, right? And around the stars could be planets and moons and cars. How many galaxies? Each on average with how many stars? Pause, know that, connect it. If you just listen to people, if you passively learn, you will not wire your brain. You have to do some activities to do that repetition. Just like a language course, you got to do it, you got to try. About 100 billion galaxies. Way too many. Remember 100 billion 1 billion heartbeats, about 1 billion seconds, is about 32 years. A billion's a big number. Each on average with, this is nice, about, some with more, some with less, some big galaxies, some 100 billion stars. Each galaxy with about 100 billion stars, and 100 billion of those islands of stars. And within those galaxies, and this is the story, this is how we pull it all together, our place, your skin, right? High mass stars formed. Now we're going to see that there's a range of stars, and we're going to do that next. Okay, and I have a great analogy for you, so pick up on that. They got a lot of mass, they got a lot of gravity, right? They got a lot of gravity. They pull in, and they squeeze hard, right? So they're gonna pull in and squeeze that gas together hard. They fuse protons together. Fuse. Some people say burn. Oh, it's crazy. It's not burning. Burning is a different process. Fuse. And as they fuse atoms together, we'll see the nuclei of atoms, protons and neutrons. We say they live. And they squeeze and pull so hard that they live fast or fuse fast through cycles. We'll talk about that. And then they explode or die young. They live fast and they die young. Remember that. And that's really important that they have short lives. Yay, we're glad. Go. Yeah. Why is that good? Because we need them to turn our galaxy into not a big cloud of hydrogen and helium, but these first generation of stars, the large ones, will make the bigger atoms like carbon, oxygen, iron, etc. Stuff for rocks. Okay? That's the story. And let me make sure you can come down here. Sorry about that. All right. Strong gravity. Squeeze hard. That's like makes that process go through. So people talk about it burning and using up the fuel. That's an analogy. But what's really happening is fusing. It's not a good analogy. I mean, it gives you an idea. But the squeeze, this happens fast. They explode, die young. They send out the bigger atoms. Phew! Now we're not just a bunch of hydrogen and helium. I mean, well, you might have a lot of balloons for your party, but you're not going to have any nachos. I'll tell you that right now. So let's finish off this introduction. Let's get to where we are. Right? And where we are is in our Milky Way galaxy. Let's do that. All right. Let's talk about that. Our Milky Way bar galaxy, I like that, Milky Way bar. It's a barred spiral. About halfway from the center, what happened? Let me get that, make sure you're good, okay? Well, groups of stars formed about halfway from the center, all around in the galaxy, right? Throughout the galaxy, this is supposed to be Milky Way. It's not, it's wrong. It's not a spiral, it's a barred spiral. Now we know. Hard to figure that out. Groups of galaxies formed early. Groups of stars formed early. Now I'm talking about in our, right? Maybe solar systems, maybe life, but here's the thing about life, right? Maybe a big star formed. Maybe some planets formed around it. But in the first generation of stars, what do you have? hydrogen and helium. Again, not a very good party. Okay? So maybe not in that first generation. Maybe there's another generation though, right? Now, they do live a pretty short life. You can look it up. It's too much information if I go there. So maybe the first generation, created stuff, and maybe it came back to another generation of stars that now had some carbon, nitrogen, etc. And around them some planets, and maybe they had life, and maybe then it exploded, and oh, bummer. And we'd like to get some ancient signal from a sadly dying civilization. Look at Star Trek, or something like that, and people think about this. Could it be? Yeah, I suppose so. So the high mass stars like Big Mama, who we just named, fuse, live, or fuse, fast, and die, or explode. We'll talk about that. Young. And those high mass stars fuse carbon, oxygen, 6 protons, 8 protons, 26 protons, etc. We'll talk about that. And then they can't do any more because they haven't got enough gravity. They explode. And that gas that got exploded out, eventually send out, will come together because maybe slow, but we got a lot of time in astronomy. And it comes together into another generation of stars and solar systems. But now these have the larger atoms, bigger or other atoms, carbon-based atoms, something about that, hydrogen and oxygen, something about water, right? All this stuff formed in a star. Yours, mine, all this, right? All this, these atoms. So that's what happened in our Milky Way galaxy. And when we talked about, in chapter 7, we talked about the basics of how any star formed. We talked about ours and our solar system. We study ours. It's the only place we can go to with spacecraft, right? And the basic idea, but this was like any star. It's the simple introduction to how this works without getting into those details that astronomers do. Some cool gas cloud pulls in by, of course, gravity. We study the laws. We need the laws of physics. We need the laws of gravity, laws of motion, the laws of electricity and magnetism, all kinds of great stuff. Anyway, it pulls in by gravity. It's easy to get. If you push something, you probably aren't going to push right through the center. You push to the side. You push your friend to the side tonight on Cinco de Mayo. They're going to start spinning, and maybe you spin them and you dance and do all that stuff. Stuff starts spinning. Gas cloud is spinning. Pulls in, spins faster, flattens into a disk. We talked about why that is. Most of the gas goes to the center. In our solar system, that's our sun, but that would be a star. You can have 2 stars forming and all that. We're not going to go there, but just this idea around that star, all that gas, the leftover, which is very little compared to what's there in our solar system, very little. You have condensation, differentiation, accretion, sweeping it up, becoming planets and moons and leftovers. But as it was doing that, lots of chunks were, pulling on each other and slamming into each other, heavy bombardment, maybe moving around through migration, and in that bombardment, boom, perhaps carbon-based molecules, organic molecules, can be sparked to create amino acids, and if there's an environment like water, whatever it takes for them to replicate, you have life. So, stars, those little dots, those silly, silly little dots. What are they, right? What are these things? We sit out here with our ancestors and we wonder, What are those dots? And now we know quite a lot. Let's go for it.